Hi, welcome back to LeetCode. So in this video, we discuss the third problem from today's weekly contest 467. The problem name is subsequent sum after capping elements. So you are given an integer array nums of size n and a positive integer k. Okay, so an array kept by value x is obtained by replacing every element's nums I with minimum of nums I or x. That means like if the current number is nums of I is greater than x, so it will be actually replaced with x, or it will be, if it is smaller than x, then whatever the number it is, so it will be that. So for each integer x from 1 to n, determine whether it is possible to choose a subsequence from the array kept by x such that the sum of the chosen elements is exactly k. So we have to return zero index boolean array answer of size n, where answer I is the true if it is possible when using x is equal to I plus 1 and false otherwise. So let's see the example one, then it will be easy to understand that we actually have some input, one input array. Okay, so first of all I will check that I is equal to 1. Is it possible? Like I know our target sum is k, this is your target sum. So for I is equal to 1, that means that if that any number in the input array is greater than I, so it will actually change to I. Okay, so check that after this replacement, what are the actually in array actually I will have modified array. So can I actually get any subsequence whose sum is actually k? So either it will be true or it will be false, right? So first I'll check with I is equal to 1. That means our capping value is 1. So that means any number in the input array is greater than 1. So it will be changed to 1. Next I'll change to I is equal to 2. So I'll check that after keeping the value as 2. So after I'll actually modify the input array. So I'll check that can I actually get any subsequence after this from this modified array whose sum is actually k or not. So for this example one, so you actually have 4, 3, 2, 4. So k is equal to 5. So I know our target sum is 5. Okay. First of all, I will check with I is equal to 1. So after that, our modified array will be what? 4 elements present in the input array. So 4 is greater than 1, so it will be changed to 1. 3 is greater than 1, so it will be changed to 1. 2 is greater than 1, it will change to 1. 4 is also greater than 1, so this is the modified array, right? So now I will check that can I actually get any subsequence from this array, the modified array, from this modified array. Can I actually get any subsequence whose sum is actually k or not? Okay, k is actually 5. So if I take all the elements, still actually our sum is 4. So we can't take this. So that's why here the answer is false for the first I is equal to 1. Next, I is equal to 2. So again, I have to modify the input array. So what is actually the array was input array 4, 3, 2, 4. Okay. So first of all, I is equal to 2. So first of all, I modify the 4 is greater than 1, greater than equals to 2. Yes. So it will be modified to 2. 3 is also greater than 2. Yes. So it is also modified to 2 is okay. 4 is greater than 2, so it will be also modified to 2. So this is now a modified array. In k, I know k is constant. The target sum is constant, 5. So can I get any subsequence whose sum is 5? No. You can just see that 2, 1 is 2, second 2, then 2, 2, 2, right? You can see that we can't actually get any subsequence whose target or sum is actually 5. Not possible. So for this also, our answer will be also false. Got it? Next, see the next example where actually the answer is true. So let's see how actually getting this true. So next will be I is equal to 3. Keeping value is 3. And our array is 4, 3, 2, 4. Right? 4, 3, 2, 4. Now actually modify the input array. So 3, 4, first element is 4. 4 is greater than 3. Yes. So it will be changed to 3. 3 is okay. 2 is, it is smaller than 3. So we can't actually change to 3. Next is 4 is greater than 3. Yes. Now it is changed to 3. Got it? So this is now modified array. So our target sum is k is equal to 5. So to check the can I get any subsequence from this modified array whose sum is still 5 or not. So for that I'll check any subsequence. First is suppose 3, and next is this 3. So this actually sum is 6. So this is not possible. This is not a valid subset. Next is this 3, this 2. Yes, this sum is 5. Just 3 here and 2 here. You can take also this 3 and 2. This is also possible. This 2 and 3. This is also possible. But at least we got one subsequence whose sum is actually 5, which actually is equal to k. So for this, our answer will be true. Clear? So what is the brute force approach we can think after this iteration, after seeing this example? So that we actually have one input array, right? I know how k is actually our target sum. So this is kind of knapsack problem, right? So I know I will check for I is equal to 1 to I less than n, I plus plus. So after each I will actually I will get one modified array, right? One modified array after replacement of all the elements with the capping element, right? So I'll get this modified array. So from this modified array, I'll check that get or check subsequence from this modified array. I will start from 0, and I know target sum is k. So either it will return true or false. So this problem, whatever actually the check function to check that can actually get in subsequence whose sum actually k or not, you will see that the target sum, right? This is one famous problem when you start any DP problem, right? So there is one problem that we will given some target sum and we will have some input array. Now this is now fixed. The modified array is now fixed to check the can I generate any subsequence whose sum is k or not. So after that we can actually I can actually use that solution here to check that, right? So for that actually it will take big of n, right? To check that can actually get any subsequence or not, it will take big of n, right? And this is also big of n, right? So it is almost n square. So this is actually the optimal approach to check any modified actually array like any subsequence is possible or not. So to how actually we can optimize this big of n, like normally it will actually check all the subsequence, right? Like how many subsequences are possible. Suppose we actually have 3 elements, 1 2 3. So brute force approach will be I will try to generate all the subsequent. One is 1, another is 1 2, another is 1 2 3, then it will be 1 3. Initial I generate 2 2 3, right? Then another is 3. Got it? Initial I generate all the possible subsequences. Then it will check that this subsequent sum is k or not. This subsequence is k or not. So if whenever I get one subsequence whose sum is k, so I return true from that point, right? So how many subsequences are possible? 2 to the power n, because one number actually have two options. Either it will be part of the current subsequence or it will not be part, right? So that is the two options. So 2 into 2 into if there are n number, so it will be actually 2 to the power n. All right, clear? So that's why this will take ultimately n into 2 to the power n. So this is not the big of n. So big of n is the optimal approach, but this is actually the normal approach. It will take n cross 2 to the power n. 2 to the power n is to check that can actually get any subsequence or not, and this big of n is to check all the capping. Like first of all, first cap value will be 1, then 2, then in this it will go up to n, right? So how should I do optimize the to check function that can I get any subsequence or not? So this is subsequence, right? So there is, that means here actually order is order is not mandatory. Like they do not actually ask to return any ordered value, right? Whatever the input array, we don't need to order that order. Ultimately we have to return true or false, right? So if I sort the input array first in the ascending order, suppose what is the I have 4 3 2 4. So if I sort this in the ascending order, so it will be 2 3 4 4, right? So first of all, I know I is equal to 1. So I actually have some dp vector to check that suppose 100. So I want to actually, this is all actually instance is false. This indicates that can actually generate this dp of I. I indicates the sum. Can actually generate any subsequence whose sum is actually I or not. Okay, if it is true, that means I can generate one subsequence whose sum is actually is I. it is false, that means there is no subsequence till now whose sum actually is I. Got it? So suppose actually I got actually maximum sum is 100. Initialized to is false. Now I is equal to 1. So I know what is the capping. So I will actually iterate from left to right. Okay, first value is 2. So that means whatever the number is present in the right side of this, all will be actually changed to I is equal to 1. Right? Because this current number actually is greater than the I. That means all the numbers will be present in this is sorted. So that means whatever the number is present in the right side, that is also greater than the I. So I can assume that all the numbers will be changed to I is equal to 1. Now this actually indicates the which sum actually I can generate till now. Now I will say that, so there is no actually number, so I can actually convert this into the like there is no number which is smaller than the current cap. So whatever number is present, that will convert to I. I means 1. So how many numbers I can convert? Suppose there is one count variable. That means total number is 4 and 4 minus 0, 4 number I can change to I is equal to 1. Right? I can change. So suppose first of all I do not want to change any number to I is equal to 1. So that means what is the sum actually I want actually, that will be k minus the k minus k dp of k. If I don't want to convert any number, so at that time actually I need to check can I actually convert dp of k or not. Can I actually have actually found any substance whose sum actually k or not, right? If I do not want to convert any number, suppose I have converted this one, say 0. Next, suppose I have converted only one number. So that time, that means I have taken one number. Suppose this 2 actually is converted to 1 now, right? So that means what is the number I want to know? K minus I. I have to check that can I actually convert, have I actually got any, found any subsequence whose sum is k minus I, because this number actually changed to 1. So that means k minus 1 is our next target, because our target sum is actually k, but I have one element whose value is I. So what is the remaining sum actually I want actually k minus I. Got it? This is one actually I change one number. Next actually I can change two numbers also. That will be dp. Then actually our target sum will be k minus 2 into I, because I have changed two numbers. All the numbers will change to I. So that's why whatever total sum it will contribute into the sum, that will 2 into I, two numbers. So I'll check that this number sum actually present or not. Have I actually found this or not? Right? So you can see that actually all are actually false, because I do not have found any subsequence whose sum actually any it does not modify any dp vector. Right? So that's why this will be actually ultimately false. So I have changed all the numbers. T is equal to 3. That also I have checked. K minus 3 into I. Then actually I can change 4 elements. So dp of k minus 4 into I. Got it? This is for I is equal to 1. Next I'll go to I is equal to 2. And our array is 2, 3, 4, 4. 2, 3, 4, 4. Okay. 2, 3, 4, 4. Yes. So still actually I am pointing here. Now see that okay, this 2, this 2. So this will be also converted to the I, because this number actually is greater than equals to the current number. So whatever number is present in the right side, that will be also converted to 2. Clear? Just visualize the diagram step by step. So our dp vector is still all actually still false, right? Again I'll try to convert. So how many numbers I can convert to I? So that is total number actually is 4, and I can convert 4 elements. You can see that 4 actually elements, these 2 can actually convert to 2, 3 can be converted to 2, 4 is converted to 2, 4 is converted to 2. So 4 actually element, maximum 4 elements I can convert to 2, right? Capping. So suppose I'll check that if I do not want to convert any number. So what will your target sum? So dp of k. I'll check that this is true or false. So this is still false. Okay, I'll continue to convert this one number. That will be dp of k minus I. I'll check that this is true or false. This is still false because I have not modified the dp vector till now. Next I'll try to convert this two numbers. That will be dp of k minus 2i. This will be, I again check that this is true or false. Next I'll check for if I try to convert 3 elements, then let's try to check with 4 elements. Okay, so this is all actually false, so that's why our answer of 2 will be false. Previously answer of 1 was also false, right? Now I'll go to I is equal to 3, and our array is still 2, 3, 4, 4, right? And still we're pointing here. Okay, and our dp vector is still false, correct? Now check that these two can actually add this into the subsequent. Yeah, because this is smaller than 3, so I can't actually convert this, because this is the maximum value I can actually take. So what I can actually do, so I know that our target sum is k. All right, this is your target sum, and I know this actually contribute up to 2. This can contribute maximum 2. So I'll actually check from k to 2 which sums I can generate. So that is depends on, suppose I know that our target sum is k. Okay, so I'll check that dp of k, can I generate this or not? So it depends on what? It depends on dp of k minus 2, right? Because if I can generate k minus 2, suppose actually if it is a straight line, then it will be easy to understand. Suppose I can, this is 3 and this is 5 and this is actually 2. So if I can generate 3, then actually I can generate 5 by using this current element. 3 plus 2 is equal to 5. So that's why I can generate 5 or not, it depends on k minus 2, because I can actually add this current element 2, and what is the remaining sum? That will be the 5 minus 2, 3. Got it? So it depends on dp of k, it will be true or false, it depends on k minus 2. Next I'll go to dp of k minus, can I generate this or not? It depends on dp of k minus 1 minus 2, and it can go up to 2. Why 2? Why not 1? You can ask me, right? So by using this 2, because I know the current element is 2, right? Makes sense. Like current element value is 2. So can I generate any subsequence by using 2 with 1? Not possible. Total sum actually I'm saying that 1, but I have to add this 2, so it is possible 1 plus 2, like 0 plus 2, it is still greater than 1, right? So this is not possible. So that's why minimum sum actually I can generate, that is at least 2. This is clear. That's why I will go up to dp of 2. It will start from k, because the maximum sum actually I want to generate, that is k, and minimum sum actually I can generate, that is 2. So why actually I'm explaining all the actually sum? Because it may possible that in future I got one more, suppose one more element, that value is 1, which actually by using that I can actually generate the target sum, like 3 plus 2 plus 1, 6. So if our target sum is k is equal to 6, then actually I can generate this. So that's why I'll mark this as false, true, to help me in the future. Got it? So that's why I'll explore all the possible sum actually I can generate by using the current element 2. Got it? So you can see that which in the dp vector now, the state of the dp vector. So k is equal to, suppose here actually it is k is equal to what is the k value? K value is actually 5. Okay, k value is 5, and I'll start from 5. So dp vector is still all are actually false, right? Okay, so 0 will be always true. Why? Because I know that without using any element in the subsequence, I can actually total sum will be 0. So this will be always true. Okay, for the 0. Rest elements are now false. Now I want to know that can I generate 5 or not by using the current element 2. So 3, 1, 2, 3, 4, 5, 6. Yeah, 3. So 5 minus 2, I'll go to the index 3. 3 is still false. So we can't actually generate 5 till now. Okay, next I'll go to the 4, right? 4, by using the current element 2, can actually generate any subsequence whose sum is 4. So 4 minus 2, I'll go to the index 2, it is still false. So this index 5 will not be modified. Next I'll go to the actually 3, can I generate any subsequence whose sum is 3 by using the current element 2. So 3 minus 2, the remaining sum it is actually 1. 1 is still false, so we can't generate 3. Next I'll go to the 2, can I by using the current element 2, can I generate any subsequence whose sum is equal to 2? Yes. How? So I'll go to the dp of 2 minus 2 means dp of 0. dp of 0, what is the value? True. So I can generate one subsequence whose sum actually is 2. So it will be now true. Previously it was false, index 2. So this indicates that I can generate one subsequence whose sum actually is 2. Got it? Why this is true now? Clear? Got it? Now this is to check that which sum actually I can generate by using the current element. Now we have to check that actually our target is that can I generate any subsequence whose sum actually k or not, right? That is our target. Now I have to check that which number actually I can convert. So how many numbers I can convert? In the input array, it was actually 4 elements, but one number is smaller than the current capping element. So I can convert only 3 elements, right? 3 elements I can convert. So first of all, I'll check that if I do not want to convert any number, so then actually I can generate dp of k or not. So suppose I'll convert 0 number. So I'll check the dp of k or not. So this is still false. So we can't generate. Suppose I want to convert one number. So then I have to check k minus the I value will be what? 1, 2, 3. Okay, means 5 minus 3. dp of 5 minus 3. This is true. That's why for I is equal to 3, our answer will be true. Clear? What is true? Because you can see that you can just observe this. So I know that I can generate one subsequence by using 2. Okay, this is clear. I have one subsequence by whose sum is 2. Clear? Now I actually have many more elements which actually convert to the capping element. That actually 3, 4, 4. Alright, these 3 elements actually I can convert to I is equal to 3. Alright, 3, 4, 4. Yes. So first of all, I'll convert this. I have not converted any numbers out of these 3 elements, right? So I've taken this from this subsequence without converting any number. Can actually get any subsequence whose sum is k or not. So I saw that there is no subsequence whose sum is k. Now I will convert this number to I is equal to 3. Okay, so this will now convert to 2. So that means 2, 3. You can just see that if I add this 3 into the subsequent, what is the sum? Sum is now 5. That is actually k. So that's why our answer is true. Clear? Have you actually visualized the state, how it is changing, how it will optimize that? Now you can see that previously it was actually I will explore all the subsequents, then actually check that any one of subsequent sum is k or not. But here actually you can see that in the future, like for the next time, like 2, 3, 4, 4. Next time I am actually here, suppose 3. For that time, I don't need to check that can actually generate any subsequence 2 or not, because this is already stored into the dp vector. Alright, this is already stored. Yeah. Right. So that's why it will take big of n to check. And it is actually previously means to check each capping. This is also take big of n because I will be shifted to 1 to n, and to check that can I which subsequence which sums I can generate from the by using the current element, that will take also big of n. Clear? So ultimately it is actually optimized to from big of n into 2 to the power n to big of n into n. Clear? This is clear. So for that, now go to the code, then it will be easy to understand also more. So first of all, sort the input array in ascending order to ensure that whenever I stop that, I know that whatever numbers will present in the right side all actually convert to the current kept element, right? Kept value. And I need the vector of dp to know that which sums I can generate. Alright, so I know what is the input size n. So that means I have to check each kept value from capping value from 1 to n, and answer each like that size also same n. Initially it is false, and dp of 0 of equals to 1 means I can always have some subsequence whose sum is 0. That's why it is 1. 1 indicates that I can generate. I have some subsequence whose sum is 5. Okay. Last ID indicates that which number actually I have converted or it's part of the subsequence. Got it? That means which sum is, or the last index whose value is the less than the current capping value. But and int I is equal to 1, I less than equal to n. That means I have to check each capping value from 1 to n. So I'll check that whatever the last index I have can be part of the current subsequence or not. So what is the condition? I will check that this is less than n. That means we have some element in the input array, and I'll check that whatever number is present in that index, that should be less than I. Then it can be then actually it will not be converted to the capping value I. It should be smaller than I. Then actually I can actually part of this. So if it is part of, it can be part of this subsequence. So then it's like check that which sum actually I can generate different sums. So I'll start from j is equal to k. Maximum sum actually I want to generate k, because that is our target sum, and this minimum sum actually I can generate by using the current element, that is whatever the value actually I have nums of last id, right, and j minus minus. And what is the, it depends on what I can generate the current sum or not. It depends on that can I generate j minus current element or not. So dp of j, that is our target sum actually I want to generate, and it depends on I can generate or not, because this is, or because it may possible this current subsequence it is returning false, but from other subsequence I got one true. I actually have some valid subsequence, but ultimately we have to take the or of that. So I will check that j minus the current value, j minus the current element value, can actually generate that subsequence or not. Like if I generate that subsequence, left subsequence, then actually I can generate the current subsequence, right, by using the current element. Clear? So I'll actually check all the possible sum I can generate. Next, after I have already consumed this element in the subsequence, so I actually increase the last index to the positive plus plus. Got it? So this while loop will run till actually we have some element whose value is greater than equals to the current capping value. Right? So it will stop that time only. Either it will reach the end of the input array, or it actually reach one. It actually have some value which is actually greater than equals to the capping value. So then actually I will check that how many numbers I can convert to I. That means how many numbers are greater than the current element. So that depends on the n is the total elements and last index. Clear? So each number it will have two options. I can convert or it will not be converted. Right? So first of all I will try to take that. First of all, do not convert any number. Like which number actually larger than the current capping value, do not convert that. So that is j is equal to 0. J indicates that how many numbers I want to convert to I, and it can maximum can convert count, right, present on the right side of that, right, and j plus plus. Suppose first of all I do not convert any number, so that's why j is equal to 0. Next I will convert only one number, so that will be actually j is equal to 1, right. So suppose j actually indicates that how many numbers I can convert. I know what is the capping value, so what is the sum actually I can contribute? I into j. That many sum actually I can contribute by using the current element. So I'll check that if k greater than k less than weight, that means I can break from here, because I can't actually reach to k, because this weight is already greater than the our target sum. So I will break from here. Else I'll check that can I actually generate this. So what is actually sum actually I have to check k minus k is the target sum, and weight is the sum after converting some elements. So k minus weight. Clear? dp of k minus weight, I'll check that this is true or false. If it is true, that means I can convert. So I will actually mark this answer of I minus 1. This means current capping value. I have some sequence whose value is k. So I mark this as true and break from here to go to the next capping value I plus plus. Got it? So after this, checking all the capping value, I will return the answer vector. Initialized is false, and it is only modified to true at this time only. Clear? So if you have any doubt, you will comment on that, and also you can also see this video one more time if you found this actually complicated. Okay, and if you're not a subscribe, please subscribe channel. Thank you. Bye.